Welcome back. My name is Satyajeet Sahu and today we are going to discuss the important formulas for your Geotech for your upcoming GATE examination. Okay. So but the comments are coming. So I am waiting for your comments. Okay. So first of all you all comment your names, okay, and your places so that I can know that who all are attending the session. Yes. Okay. So comments have started coming. Yes. So my name is Satyajeet Sahu and today we'll be revising the concepts of Geotech, the important concepts. Welcome Hemant, welcome Afrit, welcome Rasmita. You're the first ones to come. So more students are joining in. Welcome Mukul, Mukhil Krishna. So welcome everyone to this session. Okay, warm welcome. Yes. Okay, welcome Deepak. Very good. You're from Kadappa. Okay, nice. Okay, so let us start today's session on the Geotech important formulas. Welcome Survi, Deepak Chaudhary, Nikki Menon, right? So many students are joining in. Yes, that's great. Okay, so let us start this session. Hope you all are doing good. Okay, my name is Satyajeet Sahu. You might be knowing me. If you don't know me, doesn't matter. Attend the session and maximize the benefit for your upcoming examination. Okay, so we will start the session with different formulas of different important chapters. So first of all we'll start with consolidation. Okay, so I'll start with what? Consolidation. Okay, 1 second, the sound is repeating. Okay, so I just instructed our technical team, the sound echo was coming. Okay, so let us start. Okay, nice. So we'll start with what first? We'll first start with consolidation. Okay, so in consolidation, first of all we'll see what? Compressibility parameters. There are 3 compressibility parameters. What are those? They are your coefficient of compressibility, AB, then your compression index, and then your coefficient of volume compressibility. Now what is your AB? This is your coefficient of, this is what? The coefficient of compressibility. These 3 coefficients are very important. They are directly asked in the examination. You should be knowing this. This is what? Coefficient of compressibility. And this is equal to the change in the void ratio by change in the effective stress. See, when you increase the effective stress, there will be what? Consolidation, right? The expulsion of water from the pores, and there will be reduction in the void ratio, right? Because of reduction in volume. So this change in the void ratio by change in the effective stress is known as what? Coefficient of compressibility. Now there's another term where students get confused, that is what? MB. What is this MB? This MB is similar to AV with a minor difference. It is what? It is coefficient of volume compressibility. It is what? Coefficient of volume compressibility. Okay, so you can see the difference is what? This term volume, coefficient of volume compressibility, and this is given by MB. This is also the ratio of what? This is also the ratio of delta E by delta sigma with an additional term. What? 1 plus E naught. 1 plus E naught. Where what is E naught? E naught is the initial void ratio. What is E naught? It is the initial void ratio. So this is what? The AV and MB. Let us go to the next term. The next term is what? CC. This CC is known as compression index. It is known as what? The compression index. And this CC is equal to what? This is equal to the change in void ratio divided by what? Log of sigma 2 dash by sigma 1 dash. Means what? When the stress changes from sigma 1 dash to sigma 2 dash, there is increment in the stress. So what happens? There is change in void ratio. Now this ratio is known as what? The change in void ratio by log of sigma 2 dash by sigma 1 dash is known as what? The compression index. This I can say is what? The initial effective stress, and this I can say is what? the final effective stress. Okay, understood this formula? Yes. So these are what? These are the three compressibility parameters which can be asked in the examination. Now this is the formula series, so we are only discussing the formula. So where to solve the numericals? Yes. So I have taught this thing in this particular video on primary consolidation. So I have taught all these terms CC, okay, AB, MB. So you can visit this lecture and you can solve questions for this particular formulas. The next topic is what? The next topic is primary consolidation settlement. Now what are the formulas which are related to this primary consolidation settlement? Let us see. The formulas are, the first formula is delta H by H. What is this delta H by H? If we have a clay layer, of thickness what? Capital H, and due to consolidation, okay, there is settlement. Suppose due to consolidation there is settlement of what? Delta H. Settlement of what? Delta H. So this is the ratio of what? Delta H by H. And this is equal to delta E by 1 plus E naught. This is what? Delta E by 1 plus E naught. So this I can say is the most important formula for finding what? The primary consolidation delta H. They will give you H. They will give you what? The initial void ratio. Now this changes to the final void ratio. So what will be the delta E? Delta E will be the initial minus the final. So from there you can find out what? This delta H. They ask lot of questions from this formula. Now I will make you remember two formulas from this one formula. What you will do? You see this, what was MB? What was MB? MB was delta E by delta sigma, then 1 plus E naught, right? This is the formula for MB. Now see carefully, this delta E by 1 plus E naught. Yes, in place of this I can write down delta H by H, right? You see, in place of this I can write down what? Delta H by H. So what happens? MB is equal to delta E by 1 plus E naught. I will write down what? Delta H upon H and then del sigma. Yes. So from here what I can get? Delta H is equal to MV delta sigma into H. Yes. So in the examination they are going to give you the H. They will give you the change in effective stress, and then MV you have to find out what? The settlement delta H. Very easy. Let us go to the next thing. Now we know this formula. Which formula? What was your CC? CC was equal to, I can say, it was the change in void ratio by what? Log 10. Yes, sigma 2 and sigma 1. This ratio, right? This is the ratio of CC. Yes, this is the CC, right? Now in this, what we can write down from here? I can write down delta E is equal to CC log base 10, okay, sigma 2 dash by sigma 1 dash. Now this equation of delta E which I got, I can put here, right? If I put there, what I will get, you see, delta H by H will be equal to CC log 10 sigma 2 dash by sigma 1 dash divided by 1 plus E naught. Now I can take this H this side. If I take this H this side, what I will get? I will get this equation, right? I will get this equation, and these two equations are very important equations, right? These two equations are very important equations for finding what? The primary consolidation settlement. Yes. So again, where to solve the questions? I have solved a lot of questions on these two formulas, the primary consolidation settlement, in two videos. Okay. So in consolidation settlement and numericals on consolidation settlement, I have used these three formulas. Okay, these three formulas which we saw for what? Your primary consolidation settlement. You can see these videos. These videos are available in this particular YouTube channel. Okay. So I will give you reference of many videos. Okay. I will give you reference of many videos. You can watch those videos. If you have watched them, you can see that as revision. Okay. Solve the questions from these formulas. Let us go to the next topic. The next topic is what? degree of consolidation. Now what is degree of consolidation? The degree of consolidation is represented by U. This is the settlement at any time H, yes, sorry, any time T by what? The ultimate settlement into 100. What is the meaning of this? What is the meaning of this? You see, suppose I have a clay layer. I have a clay layer. Okay. I have a clay layer. Suppose its thickness is capital H. Okay. Suppose its ultimate settlement is delta H. Means what? There will be settlement of, I can say, suppose it settles by delta H. Yes. And how to find out delta H? We have seen. This is known as what? The ultimate settlement. This is known as what? The ultimate settlement, right? The ultimate settlement. Yes. Now this is going to take some time, right? Suppose this is t is equal to 0 and suppose this is t 1 time. So it takes t 1 time for this ultimate settlement. Now if you see in a time in between them, if you see in a time in between them, means what? I can say t greater than 0 and less than t1, right? This is t1 is what? Time taken for ultimate settlement. Now in this t time also there will be some settlement. Suppose small delta H, and you can see that small delta H is less than the capital delta H, right? So I can say this small delta H is the settlement at time t and capital delta H is the ultimate settlement. Now this ratio we get as what? The degree of consolidation. I can say what? By how much amount the consolidation is done. That is what? Degree of consolidation. Now I have solved a lot of questions on degree of consolidation in a particular video. You can go to this video and solve the questions. Let us go to the next formula. The next formula is about Tezagi's theory of one-dimensional consolidation, right? As per Tezagi's theory of one-dimensional consolidation, we find out the time taken for consolidation, right? So here we introduce a term known as what? The time factor. We introduce a term known as what? Time factor. Now what is time factor? We call that as TV. Okay. This time factor is equal to pi by 4. We got the degree of consolidation in the previous slide. So degree of consolidation divided by 100 whole square. Now we use this formula when U is less than equal to 60%, or else what we do? This is equal to 1.781 minus 0.933 log 10 100 minus U. Yes, we use this formula when U is greater than 60. Now what we do with this TB? What we do with this TB? This TB can be related to the time taken for consolidation by this equation CB T by D square, right? Now what is this T? This T is the time taken for U percentage consolidation. We saw how to find out degree of consolidation in the earlier slide. So once you get the degree of consolidation, for that degree of consolidation, you can find out TB by using these equations, right? By using these equations, you can find TV, yes. Now once you find TV, you can use this formula to find out this time taken for that particular percentage of consolidation. What are the other terms? The other terms are CB. What is this CB? This CB is your coefficient of consolidation. What is this CB? This CB is coefficient of consolidation. Yes. And what is the formula for this? The formula for coefficient of consolidation is the permeability, coefficient of permeability divided by what? Divided by gamma W into MB. We saw MB. Yes, in the other equations we saw MB. Now this is the coefficient of consolidation. Understood everyone? Easy. Now what is this D? What is this D? This D is the drainage path. Sorry. This D is what? This D is the drainage path. Now how we find out the drainage path D? What is this D? This is your drainage path. Okay. Now how we find out drainage path D? That depends on the drainage conditions. Suppose we have a clay layer, okay, and it is draining both sides. Means what? The water can come out from both ends. It is what? Double drainage condition. It is what? It is known as double drainage conditions. So if there is double drainage conditions, and suppose this clay layer thickness is capital H, we say that the drainage path is H by 2. It is what? H by 2, right? Now when we have single drainage conditions, means what? Suppose water is coming out from one end only. In that case, what we do? We take this drainage path as equal to H. This is what? Single drainage and double drainage. Okay. So here we can find out what? The D, drainage part D. We also saw how to find out CV, the equation for CV. Now we saw how to find out TV. And from there I can find out what? This time taken for consolidation. Okay, so these are the formulas related to what? Time taken for consolidation as per what? Your Terjaghi theory of one-dimensional consolidation. Now, I have taught that in details. Here we are only discussing the formulas, okay? The derivation and other related things I have already taught in details. They are available in this particular channel, Time for Consolidation. You can always visit and see the numericals. You see, we have a video on time for consolidation. We have a video for what? The numericals on time for consolidation. Yes. So these are the important formulas. These are the important formulas we saw for what? We saw for your Terzaghi theory or Terzaghi theory of one-dimensional consolidation. Let us see the next thing. The next thing is shear strength. Okay. Let us go to the next thing, that is what? Shear strength of soil. In shear strength of soil, the first thing is direct shear test. Okay. Now, what is the equation we use in the direct shear strength? That is the shear strength. Okay. Remember this equation? You know this. We are just revising. The shear strength, yes, of soil will be equal to what? The normal stress, normal effective stress into what? 10 phi plus C. This is the equation, right? We use this equation in direct shear test. What is this C? This C is the cohesion value. This C is the cohesion value. And what is this phi? This phi is angle of, it is the angle of internal friction. Yes. So we use this equation in your direct shear test. Let us go to the next test, that is what? Your triaxial test. Now in triaxial test we have a sample, yes. In a triaxial test we have a sample and it is subjected to what? Confining stress from all sides, right? It is subjected to confining stress from all sides. So sigma C, yes, from all sides. Sigma C from all sides. Now this sigma C is known as what? It is known as the confining pressure. Known as what? The confining pressure. So it is known as confining pressure. It is known as what? Cell pressure. Okay. Cell pressure. Okay. Now what we do? We apply additional stress along the axial direction. Now this additional stress, sigma D we call this, right? This sigma D is what? It is the additional, it is what? The additional axial stress. It is what? The additional axial stress. Yes. It is also known as what? It is also known as the deviatoric stress. It is also known as what? The deviatoric stress. Also known as deviatoric stress. So this is what? This is your sigma D. Now, when you keep on applying and increasing this axial load, okay, so what will happen? This soil sample will fail. The soil sample will fail. And this will be known as the failure angle alpha F. This alpha F is known as what? The failure angle. It is known as what? The failure angle. And this alpha F is equal to how much? 45 plus 5 by 2. Yes, very important formula. The failure angle with the horizontal is how much? 45 plus 5 by 2. Now what happens? This particular sigma C, this becomes what? The minor principal stress sigma 3. Yes, this becomes the minor principal stress sigma 3. And this sigma C plus sigma D, it becomes what? The major principal stress sigma 1. Yes. So what will happen? Sorry. So what will happen? You see, what is sigma 3 here? Sigma 3 here becomes sigma C, the cell pressure or confining pressure. What is sigma 1 here? Sigma 1 is equal to sigma C plus sigma D. Yes, very good. Now this is sigma 3 and this is sigma 1. Okay. Now if you know this alpha F, then you know your phi, right? Now how to find out the cohesion? For that we use a very important equation. What is the equation? The equation is sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2, yes, plus 2c tan 45 plus 5 by 2. It's a very important equation, right? Okay, very important equation. Now you see, you know phi, yes, you know sigma 1, sigma 3, you can find out what? Your cohesion, right? It's a very important equation used in your triaxial test. Okay, now some more conclusions from this equation. You see this equation I can write down like this also, right? Sigma 1 is equal to sigma 3 tan square. This 45 plus 5 by 2 is actually alpha f, right? Yes. So I can write like this, 2c tan alpha f. I can write like this. Now you see this tan square 45 plus 5 by 2 is also what? It is also 1 minus sin phi by 1 plus sin phi. This is another form of this equation, what? Tan square 45 plus 5 by 2. Okay, very good. Now they will ask a lot of questions from this equation, right? They will ask a lot of questions from this equation. They might be giving sigma 3, they might be giving cohesion phi, they will ask find sigma 1. Yes, questions like this will be asked. In this, prominent question is what? When the cohesion is 0. See, when the cohesion is 0 for what? For cohesionless soils like sand, what will happen? You see the second equation goes away. So I can write down what? Your sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2, right? Yes. So from here you can see, you can find out what? Tan square 45 plus 5 by 2 is equal to what? Sigma 1 by sigma 3, and tan 45 plus 5 by 2 will be what? I will take a square root both sides, right? So now if you can find the sigma 1, sigma 3 is given, you can easily find out phi, right? But this equation is only applicable when? It is only applicable when the cohesion is 0. Then only C is becoming 0. Now it has another form also. What you see from here, I can write down what? Sigma 1 is equal to sigma 3 1 minus sin phi by 1 plus sin phi. Yes. So if I write this equation, what will happen? You can just rearrange this equation and I get another important equation. What? Sin phi is equal to the difference of the principal stresses, sigma 1 minus sigma 3, divided by what? Sigma 1 plus sigma 3. So it is another important conclusion. Directly they will ask in the examination, means what? They will give sigma 1, they will give sigma 3, they will ask you find out phi, and obviously this equation is valid only if cohesion is 0. Yes, otherwise you have to go for the original equation. So I can say that I am little tired, but continuously speaking for 24 minutes, but I will speak more also. So let us have some talks also in between. You people also might be feeling little bored because so many formulas are going on. Okay, so the next is the unconfined compression test. Okay, so what is this unconfined compression test? Tell me now. I'll ask you students. What is this unconfined compression test? It's a special case of your triaxial test. Now what happens in it's a special case of triaxial test. So what happens in your unconfined compression test? You answer. You answer me. Answer me in the comment section. What is this unconfined compression test? Tell me. Where is my scale? Here is my scale. Write down. Oh, very good, Hemant. That's great. Very good, Hemant. Others? Yes, Karthi is also active. Very good. Very good. Very good. Yes. Sigma 3 is 0. Yes. Sigma 3 is 0. So if I draw the more circle here, I will get something like this. Yes, I'll get something like this. Here you see sigma 3 is 0. Sigma 3 is 0 means what? The confining pressure is 0, right? The cell pressure is 0. And it is normally conducted for your clays. Yes. Doesn't mean that we don't conduct for other type of soil. We also conduct for silty clays also. But normally conducted for pure clays. So in pure clay what will happen? We get phi is equal to 0. Yes. If you see this is the failure plane. What we get? We get your phi is equal to 0 in this. And what we get? You see this is the sigma 1. The sigma 1. See when the sigma 3 is 0, that means on the sample only sigma 1 is acting, right? Only sigma 1 is acting. Yes. And then at a certain sigma 1 there will be failure at alpha f angle. And what will be this alpha f angle? It will be 45 degree, right? Because 45 plus pi by 2, pi is 0, so I'll get how much? 45 degree, right? Now you can see that it is failing under what? Axial compression, right? So I can say this sigma 1 which we get, it is known as unconfined. One is what? Unconfined your compressive strength, right? It's known as what? Unconfined compressive strength. Very good. Unconfined compressive strength. It's also known as QU. Also known as what? QU. Now see, this is the value of cohesion. How? The intercept with the y-axis is always the cohesion. How? You see, if you see general, general shear strength curve. Yes, if I say general shear strength curve, then what type of, curve I get? I get something like this, right? I get something like this. This is the failure envelope for, shear strength. I can say this is the failure envelope. So this is the equation of shear strength, right? How? S is equal to sigma n tan phi plus c. So this is the equation of what? Linear line. And this I can say is what? The intercept, and this is the cohesion, right? This is the cohesion, right? And this is the phi angle. And therefore tan phi gives the slope. But here you can see it's a flat line because phi is 0, so slope is 0. Now this will be the cohesion value, right? This will be the cohesion value. I'll call this as undrained cohesion. I'll call this as what? Undrained cohesion. Okay. So you can see that here the undrained cohesion is the radius, whereas Q is what? This value. Yes, the diameter. So I can say 2 into Cu is equal to Qu, or I can say the undrained cohesion is equal to the unconfined compressive strength divided by 2. Yes. So very important thing of unconfined compression test. Okay. So we saw some important points. Okay. So like this, I have taught shear strength in detail. So this was all the formulas we discussed. Now the application of formulas, I have taught in shear strength of soil. I have solved very important questions also. So please do visit that lecture and solve all the questions as your revision. Let us go to the next formula thing. And also we revised now consolidation in shear strength, all the formulas I revised. Then I told you which videos you can see for, big numericals like GATE 2 marks. Now for objectives, I have solved in this particular video, I have solved 50 very important objectives for consolidation and shear strength. Okay, they're all 1 mark questions. The videos which I told you to visit, those were all 2 mark questions, but this is all 1 mark questions. You can visit this particular lecture, okay, and revise your concepts. Okay, next let us see which formula we'll see. Duffys Law means what? Permeability, right? So Duffys Law is what? Okay, if we have a soil sample, like this, right, whose area is A, okay, this length is L. This length is L means this is the drainage path, we can say. And suppose the water is flowing like this. So if the head difference between the ends, between this end and this end is suppose H. H is what? The head difference. Then I introduce a term, what? I. What is I? I is your hydraulic gradient. I is what? Your hydraulic gradient. And your I by L hydraulic gradient by the drainage path is what? Sorry, the head difference by the drainage path is what? It is the hydraulic gradient. So as per Darcy's law, the discharge which is happening across this soil layer will be directly proportional to I and it will be directly proportional to A. So we'll introduce a constant of proportionality, that is K, and this equation is what? The Darcy's law, where Q is what? The discharge of water, okay, discharge of water. I is the hydraulic gradient and A is the cross-sectional area, Yes, it's an important equation, Darcy's law. Okay. Now the next thing is determination of your coefficient of permeability. In this we have two methods, right? One is the constant head method. Okay. One is the constant head method. Now constant head method is used for what? It is used for your coarse grained soil. It is used for what? Coarse grained soil. So what we do here? Very easy. We take a soil sample. Okay. We'll take a soil sample. Okay. And let water drain through it. Okay. Maintaining a constant head H. Okay. Between the two ends. And then we will measure the volume of water. Okay. Collected in time T. Volume V. So volume V in time T. So from here I can get the discharge, right? So discharge will be what? Discharge will be V by T, and this I will equate to what? KIA, right? Using Darcy's law. So K, I will be how much? I will be this head difference and this drainage path. This is the drainage path, I can say. The length of the sample or height of the sample will become the drainage path. So I can say H by L, and area of the sample obviously will be knowing. So from here, your K will be what? QL by AH. So this way we can find out what? The coefficient of permeability for coarse grained soil. Now what happens for fine grained soil? For fine grained soil what happens? For fine grained soil what happens? The volume collected in time T will be very less. The discharge will be very less. Okay. So we adopt another method known as what? That is the falling head test. I am not drawing the diagram and all, not required now. Okay. So falling head test. In this, so look, I will just give some hint. So if this is the soil sample, we attach a small stand pipe, whose area is A, and in this stand pipe the water will fall easily. So in the stand pipe the head will fall from what? Head falls from H1 to H2. So head falls from H1 to H2. See here, the cross section area A of the stand pipe is very less, so it can easily fall. Okay. So here how we find out K? K is equal to AL by AT. What is this? Small a is the area of the stand pipe which you are using. Now capital A is the area of the soil sample which you are using, and L is the length of the soil sample, and T is the time taken for the head to fall from H1 to H2. So this is the time T taken. Okay. In this you multiply what? Ln your H1 divided by H2. So this is the equation. This is the equation for finding what? The K using what? Falling head test, and we use that for what? Fine grained soil. This is what? This is how we find out the determination of coefficient of permeability. Now we'll have some water. Okay. So hope you're liking this revision. Yes, all the important formulas are getting revised. I thought of writing the equations. Okay, writing the equations. I felt that you might like it. So please write in the comment section. Are you liking writing the equations, or if I type the equation, which one you like more? Which one you will be liking more? Please write in the comment section. I want to hear from you. Are you liking this writing thing? I'm writing the equations. Are you liking it? Writing? Others? Right? Okay, very good. Okay. So let us write other equations. Writing, very good. Chalo. So this was determination of coefficient of permeability. Okay. Let us go to the next thing. That is what? the permeability in layered soil, right? The permeability in layered soil. Okay. Now permeability in layered soil has two parts. One is the horizontal flow. One is the horizontal flow. Okay. Here I'll discuss the formula. Numericals you can visit. So you see here, not only I am revising the formulas, I am guiding you that in this YouTube channel that which videos I have taught, so you can refer those videos and revise for your upcoming GATE examination. Yes, so this is a very good idea. I thought that let me revise the formulas and also tell you from where you can solve numericals, because you see it's not possible that I solve all the numericals of Geotech in one session, right? But I have taken many lectures, so I can refer them so that you can see them. So the horizontal flow, we have the equivalent coefficient of permeability, that is equal to what? That is equal to summation of KIHI, means what? K and H of each layer divided by what? Summation of HI. This is what? K1, H1, K2, H2, K3, H3 by H1 plus H2 plus H3 plus H4. How many H are there, right? Now this is for horizontal flow. Now what is vertical flow? In vertical flow, if you see the equivalent coefficient of permeability, that was equal to, in numerator we have this summation of HI, this term, and denominator we have what? Summation of HI by KI. Now when we call a particular flow as vertical flow, when the flow is happening perpendicular to the layers. So suppose the soil have layers like this, okay? Suppose soil has layers like this, okay? The soil has layers like this, and suppose the flow is happening like this. The flow is happening like this. So here it might look horizontal, but actually this is what? Vertical. Why? Because the flow is happening perpendicular to the layers. So when the flow is perpendicular to the layers, that I call what? Vertical flow. Understood? That I call what? Vertical flow. Yes. So this thing, how to use this formula, whatever questions are asked, I have discussed in this particular video. You can visit this video. Let us go to the next thing, that is what? Factors affecting permeability. In that we have the Kajni-Korman equation, and what is that equation? The coefficient of permeability is equal to 1 by the Korman constant into gamma of the fluid flowing by your viscosity, then E cube by 1 plus E, this is the Boyd ratio, then D10 square. That means what? The K is directly proportional to D10. What is D10? It is the effective size, right? D10 is what? The effective size. Or I can say size corresponding to 10% finer particles. So you see this particular thing, they might ask question, right? They will tell that for a particular D10, I am getting this much K. They will give answer another D10 and ask what? What is the K? Means what? From here I can say K1 by K2. If I am comparing two permeabilities, it will be D10 1 for the first soil square divided by what? D10 2 for the second soil. Yes. So like these questions they will ask. Okay. And you can see that K is directly proportional to what? E cube by 1 plus C. So in this also questions can be asked. Can I say K1 by K2 will be equal to what? Your E1 cube by 1 plus E1, then E2 cube by what? 1 plus E2. Okay. Such type of questions they can ask, right? Such type of questions they can ask from this what? Factors affecting what? Your permeability. You should know these questions, okay? Okay. Or they might ask, you know, that gamma, dependency on gamma, dependency on mu. You can see that K is inversely proportional to the viscosity. K is directly proportional to gamma. So they ask questions from this. You should know this. Next thing is what? The next thing is seepage pressure. How to find out seepage pressure? That is very easy. Now first of all, there are two types of seepage. First of all, there are two types of seepage. Upward seepage and downward seepage. Now whatever is the seepage, if I are trying to find out seepage at a particular depth, seepage pressure at a particular depth Z from top of soil, here the seepage pressure PS, suppose I call this as PS, it is nothing but I the hydraulic gradient, this depth Z, and then gamma W. The equation remains same even if it is upward seepage or downward seepage. Just the thing is that when it is upward seepage, what will happen? The effective stress will decrease, right? When there is upward seepage, the effective stress will decrease. And whenever there is downward seepage, I can say what? The effective stress will increase. So I can say, if I can find out the seepage pressure, so can I say the effective stress nu will be equal to effective stress old minus this seepage pressure for upward seepage, right? And for downward seepage, I can say the seepage pressure nu will be equal to the seepage pressure old plus the seepage pressure. Understood this formula? Very simple formula, but we should know this. Seepage pressure. They ask questions from this. Now the next thing is what? Quicksand condition. What is quicksand condition? The quicksand condition is in case of upward seepage. Okay, in case of upward seepage, when we have for silty sand, okay, for silty sands type of soil, what happens that the upward seepage becomes equal to what? The existing effective stress. So what will happen? In upward seepage we saw that the new effective stress is old minus the seepage pressure. So if old means the existing one, if this one becomes equal to this one, then the net effective stress will become 0, right? Yes, the net effective stress becomes 0. Okay, so this becomes equal to this, the upward seepage pressure. I can say the upward seepage pressure becomes equal to the existing effective stress. So what will happen? Now the net effective stress will become 0. So when this happens, what we can say? The soil loses its shear strength. Why? Because silty sand already cohesion is 0, and we saw the shear strength equation. It was what? The normal effective stress 10 phi plus C. So C is 0. The effective stress also becoming 0. So shear strength becomes 0. That is what? Quicksand condition. Also known as what? Your piping. Also known as what? Piping. Now the hydraulic gradient under which it happens, that is known as the quicksand condition. And the equation for the hydraulic gradient is known as critical hydraulic gradient. It is known as what? Your critical hydraulic gradient, and this will be equal to G minus 1 by 1 plus E. Remember this? Or I can write down this as what? G minus 1 by 1 minus the porosity value. Yes. Now if I ask you to find out the factor of safety against quicksand condition or piping, that will be equal to how much? That will be equal to IC by I. IC by I means what? Whatever critical hydraulic gradient we got divided by our existing hydraulic gradient. Now this how we'll find out? H by L, right? This will find out what? H by L. Very easy. Yes. The head difference by the drainage path, and critical hydraulic gradient we can find like this. Yes. So if the head difference is given, drainage path is given, we can find out I, and we can find out what? IC also. So from that we can find out what? The factor of safety. The next thing is what? Flow nets, right? The next thing is what? Flow nets, right? So in flow nets, okay, I cannot draw the entire flow net now. I'm just giving a small idea. We have what? We have equipotential lines and we have flow lines, right? We have these as flow lines. These are the flow lines, yes. And these are what? These things are what? I can say these are flow lines. These are what? The flow lines. And I can say that these things, let me draw in green, yes. So these are what? These are the equipotential lines. These are what? The equipotential lines. Okay. So in this flow net, the most prominent equation they ask is to find out the discharge per unit width. This is what discharge per unit means what? Meter cube per second per meter. This will be equal, diagram will be given to you. This will be equal to the coefficient of permeability. Yes. Then what? What? NF by ND into the total head difference. Suppose they are giving you a dam or a small hydraulic structure like this. Okay. So I can say that in this case, I can find out the head difference very easily. Yes. Suppose the level of water is given, then I can easily find out what? The head difference. This will be the head difference, H. Now the flow net will be drawn, okay. Suppose this is the one sheet pile is there, and suppose this is the flow net is drawn like this, okay. Okay, the flow lines are drawn like this. So in this you can calculate the number of, okay, flow channels. What is NF? It is the number of flow channels. Okay, from the diagram you can find out what? The number of flow channels. Suppose here you can see this is one flow channel, second flow channel, third flow channel, and fourth flow channel. You can count the number of flow channels. If the diagram is not given but the number of flow lines are given, so I can say the number of flow lines minus 1 will also give me what? The number of flow channels, right? And how to find out the next thing, ND? What is this? The number of your potential drops. It is what? The number of potential drops. Okay. How we'll find out? Again by counting. Again by counting, you can see here this diagram. Suppose I'm seeing this diagram. The number of potential drops is how much? You see 1, 2, 3, 4, 5, 6, 7, right? So if the seepage is occurring in this manner, then I can say that there are 6, you can say equipotential, you can say potential drops. If the diagram is given, you can find it in this manner. If the diagram is not given, what you can do, this is equal to, I can say that the number of equipotential lines, okay, minus 1. Understood? If they give the number of flow lines and equipotential lines, the subtract 1, you will get what? You will get your number of flow channels. Easy. Or they give the diagram, you can count. And you can find out what? The seepage amount, right? Seepage amount. Now, this is for an isotropic medium. For an anisotropic medium, this K will be what? The equivalent K. Okay, if there is 2D flow, I can say this will be Kx into Ky. Okay, so very easy. Yes, this is about the flow nets. Let us see the next thing. The next thing is what? The next thing is about Bossin-Esquisse equation. This is what? This is the vertical stress increment. So suppose we have, okay, suppose Hindi ka bhi use kare. Actually, this is the English channel. So see, we have two channels actually. So this is the English channel. So therefore, I have to speak in English. So we have a Hindi channel also. So we have in Hindi channel also, and in Hindi channel we have teachers who are teaching in English, Hindi. So you can refer the videos if you are finding little difficulty. मतलब sorry, मैं तो इंग्लिश में हिंदी में बोलता हूँ. अगर आपको थोड़ा हिंदी में इंग्लिश हिंदी में देखना है, तो हिंदी का हमारा खुद का चैनल है अलग से. तो हिंदी का चैनल आप देख सकते हैं. वहाँ पे भी अच्छे टीचर्स हैं जो आपको हिंदी में पढ़ाते हैं. So I am teacher of in English, so I am speaking in English. Okay. Okay, sorry for the delayed response. Okay, so this is what, this you can see is the point load. So if I have a point load like this, suppose this is Q load, right? This is the Q load. Okay, so due to this point load, this is at ground level. Okay, and we are seeing a point here, and here suppose the stress increases by what? Sigma Z. Now when the load is applied, there will be stress increment. So suppose this is the point load, and I can say that this is the point load, yes, and I can say that this is the line below the point load. Okay, so this point where I'm interested in finding the stress, so this will be what? This is the radial distance R, and this will be known as the depth of that point Z, right? So if this is the radial distance R and this is the depth, so I can say the sigma Z formula is what? It is actually 3Q by 2 pi Z square Yes, then 1 by 1 plus r by z whole square to the power 5 by 2. So this is the equation, ladies and gentlemen, right? Now see, if I am seeing this equation, okay, and I am saying that just below the load, not just below, directly below the load. If I say directly below the load, what will happen? Directly below the load, R will be 0, right? Okay, you can see, suppose this point, R will be 0, right? So R is 0. If I put R is equal to 0, I get what? Sigma Z is equal to 3q by 2 pi z square. Now you can see that here the sigma z is inversely proportional to 1 by z square. So if you are taking the stress at 2 points, suppose z1 and z2, the ratio will be what? The ratio will be z2 by z1 whole square. Yes. Okay. So these questions are asked a lot, so therefore I revise them. Okay. This is what? The point load. You see, this was point load. Okay. This is what? The point load. The next thing they will ask a line load. Okay. The next thing they will ask is a line load. In line load, what will happen? The line load is an infinite line load. Okay. The line load is an infinite line load, and it is acting along the y-axis. It is imagined to be acting along the y-axis. So it's an infinite line load. It's an infinite line load. Okay. So this continues. This is the infinite load, means what? This is continuing. So this is along the y-axis. So suppose this is your x-axis and this is your z-axis, right? X-axis and this is z-axis. Suppose we have a point here. So what will happen? This point will have a x coordinate and z coordinate, right? Yes. So if x and z are the x and z coordinate, then I can say due to this load Q, small q, kilonewton per meter, yes, the stress increment at this point will be how much? It will be, you see, 2q by pi z. You see, when it was point load, it was z square. Here it will be z only. And then 1 plus x by z whole square and then whole square. So this is the formula for what? Line load. Now if you see below the line load, directly below the line load, okay, line load. So what will happen? You see here in these points, x is 0, na? Here x is 0, right? So x will become 0, and I can say this sigma z will be simply what? 2q by pi z. Now if I compare two depth and compare that depth, you can say the stresses, then I can say sigma z1 by sigma z2 is equal to what? z2 by z1. Here you can see it is not square. That square term was for the earlier case. The square term was for the earlier case. Understood? So you can say this is point load and this is what? This is your line load. The next one is what? This is for your line load. Very good. What is the time? We have been revising for last 1 hour. Yes, we see so many things. Let us go to the next thing, that is trapezoidal method. Now in trapezoidal method, what happens? Suppose we have a footing. Suppose we have a footing like this. Okay, this is a trapezoidal method. This is the footing like this. Yes. So when the footing is acted upon by a load, then there is dispersion of that particular load, or I can say the stress gets distributed. How? Suppose this is a load Q. This is the, this one is Q. This one is Q. So now when this one is Q, okay, and the base dimensions are what? B into L. Yes, B into L. Okay, so the width is suppose B, okay, and suppose the length is L. Yes, or whatever side you want to tell. Now see this thing. This can be B or this can be L depending on what you are seeing, from which side you are seeing, right? Understood? Okay. Yeah. Deepak is asking to Hemant. Hemant, please reply to Deepak. Okay. Very good. So here what will happen? There will be dispersion. Okay. The load will get dispersed, okay, at a particular dispersion angle, okay, at a particular dispersion angle. Okay. Now what is the slope of this dispersion line? The slope of this is your 2 vertical is to 1 horizontal. 2 vertical is to 1 horizontal. So if I am trying to see the area at depth Z from this particular, footing. Yes, this is not straight. Let me make it little straight. Okay, very good. So at depth Z from this particular footing. Yes, at depth Z from this particular footing. So what I will do? You see, this will be, suppose this is B, then this will be B only, right? This will be B only. Now see, what is the load dispersion we saw? 1 horizontal, 2 vertical is to 1 horizontal. Okay, or I can say, this I can write down as 1 vertical is to your half horizontal. So if in the vertical it is Z, here it will be what? Z by 2, here also Z by 2. So here I can say the change dimension will be how much? This B dash, I can say what? This is B dash, and this B dash will be how much? This B dash will be equal to your B plus Z. Similarly, the length will also increase. It will become L dash is equal to L plus Z. Very good. So what will happen to the stress at this level? If you want to find out the stress at this level, then you will take the total area Q divided by the changed dimension, or I can say the dispersion which has occurred. That is B dash and L dash. Or if I draw 3D diagram, this is the base of the footing. It is what? B and L. Now if you see at a depth Z, due to dispersion now it will be acting on a larger area, right? The same load will be acting at a larger area, and this area will be how much? I can say B dash and L dash. How to find B dash and L dash I explained, and this is what? Z. Understood? So I can say that the load has got dispersed due to which acting on a larger area, and how to find out the area I discussed. And this is what the trapezoidal method, there are direct questions from this. Also it is helpful in your consolidation. Yes, very good. Let us do the next thing. The next thing is active pressure. We'll see what? Active pressure. Now in active pressure, if you want to find, okay, active pressure means what? Retaining walls, right? So in retaining walls, if you have, a retaining wall like this, okay, and this is the backfill. This is known as what? The backfill, right? Backfill soil, I can say. The backfill soil, I can say. Now, if the height is h here, if you want to find out the active pressure at any depth, suppose I am trying to find out at Z depth, then what you will do? That will be equal to Ka into the vertical stress at that particular point minus 2C root K. Now when I say cohesionless soil, what will happen? This will become 0, and the active pressure will be simply what? It will be Ka into vertical stress. Now what's the vertical stress at a depth Z? That will be simply what? Your gamma into Z, and this is the way we find out what? Active pressure. Right? Now there are many cases, okay, and I have explained that how to not remember those formulas and draw the distributions. Like you see here, if I draw the distribution of stress, the earth pressure, you see at the top Z is 0, right? So I can say Z is 0 here. So I can say here your active pressure will be also 0. Now what will be the active pressure at the base? It will be Ka gamma H, right? Now this is the distribution. This is what? This is the distribution, right? This is the distribution. Now this is what? This is H. Now instead of remembering the formula, if you know this distribution, you can draw this distribution. I can say the total force will be area of this stress diagram. That will be what? It's a triangle. So half base into height. This is what? Ka gamma H square by 2. As I told, no need to remember these formulas. If you can draw the distributions using this formula only, Only using one formula, if you can draw the distribution, also know the effect of water table and all, then you can easily find out what? The active pressure in cohesionless soil. And all these things I have covered in a particular video, active earth pressure in cohesionless soil. I have solved 6-7 big numericals where I have tried to cover all the cases. Okay, the equation remains same. This is a formula series, right? So equation remains same. How to apply this equation into various cases, that I have explained in this particular video. You can visit this video, you can see how to solve those questions. Now, the next thing is active pressure in cohesive soil. So what happens in active pressure in cohesive soil? C is not 0. It's not 0. If it is not 0, what happens? Then I can say that the active pressure equation becomes what? Ka into vertical stress minus 2C root Ka. Yes, and vertical stress is gamma into Z. Now you can see that if I am drawing this, right? Suppose this is I am drawing, okay? This is the retaining wall, and suppose this is what? This is the backfill. So what happens at the top? Z is 0. Okay, Z is 0. So what happens to the active pressure? It becomes Z is equal to 0. It becomes minus 2C Ka. So we get a negative distribution. Okay, we get a negative value at the top, right? And this will be the distribution. So here we get a negative earth pressure, and below it we get what? Positive earth pressure. And due to this negative earth pressure, what will happen? There will be development of tension cracks, and this depth is known as what? Z0. This is known as what? Z0. What is Z0? Z0 is the depth of tension cracks. It is known as what? The depth of tension crack. Very good. Depth of tension crack. How we find a depth of tension crack? You see, at Z0, can I say the effective stress is 0? Sorry, not effective stress. Can I say the active earth pressure is 0? Yes. So you can put this Ka in place of vertical stress. I'll put what? Gamma into Z0, because Z is Z0 here, minus 2C root Ka is equal to 0. So from here what I can say? Z0 will be equal to 2C root Ka by what? Your Ka gamma. So from here you see there will be some cancellations, and I will get Z0 is equal to what? 2C by gamma root Ka. This is the very important formula for what? Finding the depth of tension cracks, which they ask a lot in the examination. Now, how to apply this, how to solve the numericals from this active pressure in cohesive soil, I have taken a full video, okay? I have taken a full video where I have solved many questions, okay? You can visit this lecture. This is what? Active earth pressure in cohesive soil. So how to use these equations, okay? So I am giving you the equations also, and I am also giving you the videos where I have taught this. You can, how to search these videos? You can go to the YouTube, okay, search this. Or what you can do, you can go to Google and write down this lecture name and my name, okay? Go to Google, write down this lecture name and my name. My name is Satyajeet Sahu, okay? Write out this and this, okay? Or any subject you want to search, or any topic you want to search, just write down Satyajeet Sahu and that topic name. You will get some video somewhere, okay? So then you can go to the YouTube link, okay? The YouTube link will be visible there. You can go and see these lectures, okay? You can go and see these lectures, okay? Next formula we'll revise is what? Passive pressure. In passive pressure, what happens? Okay, it is little different. The passive pressure will be equal to what? Kp, vertical stress. Instead of minus, we get what? Plus. And what is the difference? See, Ka was the coefficient of earth pressure. It was 1 minus sine phi by 1 plus sine phi, where H, Kp is the reciprocal of Ka. We get what? 1 plus sine phi by 1 minus sine phi. Very good. Now the next thing, okay? The next thing is stability of infinite slopes, okay? So in stability of infinite slopes, they ask mostly what? The factor of safety. Now the factor of safety is equal to 10 phi by 10 beta. What is this 10 phi and what is this beta and phi? Phi is the angle of internal friction. Now beta is the inclination, angle of inclination of a slope. You suppose we have a very large slope. So this is what? The angle of inclination of that slope with horizontal. Sometimes they write beta, sometimes they write I, same thing. So this is the factor of safety. This we use for what? This we use for cohesion-less soil only. All the formulas I will write on cohesion-less soil only. This is for dry and submerged case. This is for what? This is for dry and submerged case. Okay. Now, if we are seeing, okay, a case where there is written seepage parallel to the slope. It is written what? Seepage happening parallel to the slope up to ground level. Means what? You see seepage is occurring like this. Okay. Seepage is occurring like this. And you can see that it is occurring till this ground level, which is inclined here. So in this case, the factor of safety will be equal to, remember, same tan phi by tan beta. Okay, same tan phi by tan beta. Then what? Gamma submerged by gamma saturated. Yes, this is the formula, right? Now, if we have seepage occurring, parallel to the slope, and if it is not occurring up to the ground level, something like this, okay, something like this, see, it is not occurring up to the ground level. That means what? It is occurring like this. You can see it is, seepage is occurring, right? There is seepage is occurring, but it is not occurring up to the ground level. So here, if I am interested in finding the factor of safety at depth Z, suppose this depth is Z. At depth Z, we want to find out the factor of safety. Then we define this small h. We'll define a term that is small h. You can see this is the height of that water, okay, table I can say. Our table is like this here. And I'll give another name to the height above it. Suppose this is capital H. So here the factor of safety will be equal to, remember this is 1 minus gamma W into small h divided by what? Your gamma average into Z, this into your tan phi by tan beta. Now some student was asking, sir, how you are able to write so many equations continuously, okay, when you know so many formulas there, what is motivating you to write so many equations? Actually, when I revise for myself actually. Many students think that I am, writing for you. Yes, I am writing for you. But actually, I revise myself also. I learn myself also. Yes, and therefore I never feel bored in teaching. So similarly, when you are studying, teach yourself. Did you understand the logic? See, I am a teacher. Yes, but when I am teaching you, I try to learn. Means I try to become a student. Yes. So when you are the student and you are trying to learn, then become a teacher and teach yourself. Then you will feel motivated. Yes, then you will feel motivated. Okay. Let us come back to this equation. Okay. So here, what is this gamma average? This is the average gamma. You see, above it we will have some gamma above water table. Here we will have saturated. So you can see it is gamma into this capital H plus gamma saturated into this small h by total height Z. Okay. So this is what? The gamma average. Okay. Now I cannot derive this formula because I have derived this formula in this particular video. You can go stability of slopes. I have derived all this formula and I have solved questions. Okay. So here we are just revising the formula. So I am just mentioning because if I start deriving, it will take 15 minutes for each formula, right? So I am not deriving the formulas. So derivation of the formulas are given in these videos and also the questions. We are just revising the lectures, the formulas, sorry. The next thing we'll see is bearing capacity as per Terzaghi theory. So Terzaghi theory gave the ultimate bearing capacity of soil, that is what? C and C plus Q and Q plus 0.5 B gamma and gamma. Yes, this is the equation for finding what? The bearing capacity of soil. Okay. Now what is this Q? Q is gamma dF. What is this dF? We are finding the bearing capacity of soil for a footing at its base, na? At its base we are finding. So this becomes what? dF, the depth of footing. This becomes what? The depth of footing. Gamma is the gamma. B is what? The width. Okay, B is the width of this particular footing, or size I can say. Right? And NC, NQ, N gamma are the bearing capacity factors which depends on the angle of internal friction. There is equation, but no need to remember those equations. They will be given to you in the examination. Right? Now this equation is valid for what? Strip footing. It is valid for strip footing. Okay? Strip footing is what footing? Strip footing is the footing where the length is quite large compared to the width. Okay? So now if we have square footing, okay, if we have square footing, what will happen? This equation will change to 1.3 CNC plus QNQ. Second term is not affected. And third term changes to what? 0.4 B gamma N gamma. And if we have circular footing, they are square and circular only most of the times. The first term changes to 1.3 CNC plus second terms remain same. And the third term changes to what? 0.3 B gamma N gamma. So I can say these are the changes happening, you see. It was 0.5 for the strip footing. For square it became 0.4. For circular it became 0.3. And this 1.3 term got added for your square and circular footing. Right? Second term is unaffected. They are the important things which they can ask. We can say this is the effect of shape. I can say this is the effect of shape. If I see the effect of your cohesive or non-cohesion. So suppose I am telling it is purely cohesive. It's purely cohesive means what? Phi becomes 0. Purely cohesive means what? Phi becomes 0. In that case, NC becomes 5.7, okay, and NQ is 1 and N gamma is 0. So these values won't be given to you in the examination, and you should remember that for purely cohesive soil, we get these values. Okay, understood? Now, the next thing is bearing capacity as per Scampton. So this we saw as per what? This we saw as per the Terzaghi. Now, what is for Scampton? Now, Scampton told that his theory is valid for what? It is valid for your purely cohesive soil. For purely cohesive soil, his theory is applicable. So what Scampton told? Scampton told that the net ultimate, what is the net ultimate? It is the ultimate minus gamma dF. Okay, the net ultimate bearing capacity of the soil will be CNC for all shapes. For all shapes. That 1.3 factor is not required, Scampton told. And Scampton gave the different formula for NC for different conditions. Now he gave the formula as 5 into 1 plus 0.2 dF by B. What is dF? What is dF? dF is what? dF is the depth of the footing, B is the width of the footing. Then 1 plus 0.2 B by L. This is the equation of what? This is the equation of your NC given as per Scampton. Now this is for a rectangular footing. Now if you know this, you can find out for others also. Like for strip footing, what will happen? For strip footing, your L is quite large compared to what? B. So your L by B is 0. If your L by B becomes 0, then what happens? This equation changes to what? Only 5 plus 0.2 dF by B, right? Yes. Now for a square or circular footing, what happens? For a square or circular footing, length is actually equal to B. So I can say L by B is equal to 1 in that case. Yes. And I will get the equation as what? You see, if L by B is 1, so it will become what? 1 plus 0.2, 1.2. Na? So 1.2 into 5 is 6. So equation changes to 6 into 1 plus 0.2 dF by B. So if you know this formula, ladies and gentlemen, if you know this formula, indirectly you know this formula and this formula. Okay? So smart approach. So smart approach. Now all these equations are valid if the dF by B is less than 2.5 H per Scampton. Now if the df by b crosses 2.5, so Scampton told take them as 2.5. If I take df by b as 2.5, what will happen to strip footing? You see, in strip footing NC value how much I will get? You see, 5 into 1 plus 0.2 into 2.5. 0.2 into 2.5 will be how much? 0.2 into 2.5 will be 0.5. So 1.5 into 5 gives me 7.5. L by B doesn't become 0. Okay, sorry, B by L. Sorry. I wrote the reverse. Okay, sorry. It is B by L. Okay, it is B by L. It is B by L becoming 0. And here also B by L is 1. Anyhow, B by L 1 and B by L 0 is same. L by B is 1 is same thing. But B by L becomes 0. So I'm getting how much? 7.5. Now if you see for this square footing and all, put what? Here you put what? Here you put your df by b as 2.5, will get what? 6 into 1.5, that is what? 9 you will get. So remember, if we have diff foundations where df by b is quite large, especially in pile foundations, what we use? For square and circular piles, what we use? NC is equal to 9. Yes, and strip we use 7.5. Normally we don't provide strip piles. Therefore, when you're providing square or circular piles, we take NCS 9. This is the Scampton theory. Let us go to the next thing. The next thing is what? I have solved many questions on bearing capacity. You can visit this lecture and solve the questions. See, I am giving you the reference for solving the numericals. If you want to solve numericals, so numericals is solved. Obviously, this is a formula series, so I cannot solve questions. Okay, so we are just revising the formulas, the concepts. Okay, I am giving you the references of the videos where I have solved the numericals. You can just Google search them with my name. You will get the link. The next thing is single pile in clay. When I'm studying single pile in clay, we have to find out what? The ultimate load carrying capacity of a pile. The ultimate load carrying capacity of a pile. Suppose we have a pile like this. Okay, so in the pile, whenever there is a load, there is what? End bearing resistance. So if a load is applied, QU suppose, there is end bearing resistance, there is what? Frictional resistance. This end bearing resistance, this is what? Frictional resistance. So if I want to find out QU, it will be combination of two things. It will be combination of the frictional resistance or screen friction resistance and the end bearing. Now this ultimate load will be equal to QF plus QB. Now these are loads. Loads are what? Stresses into area. So this becomes, okay, for frictional, I take the stress as alpha into C. Alpha is the adhesion factor because there is adhesion between what? The pile and the soil. Right? This is the ground level. So here there is soil. So there is adhesion between pile and soil. So I'll take that as alpha into C as the screen friction, and that I will multiply with what? The surface area. I'll multiply with the surface area, and surface area of a pile will be how much? It will be actually equal to, if it's a cylindrical shape, means you can say circular pile, then what is the surface area? Surface area is perimeter into length, right? Now perimeter into length, what is perimeter here? Perimeter is pi d, right? If the diameter is d, then the perimeter is pi d. Okay, so pi d into L, I can say, length of the pile, right? Length of the pile. This is what? For a circular. Yes, this is for a circular. Now if it is rectangular, the perimeter will be what? 4 into the width, that is the perimeter of a square. So into L will give me what? The surface area. Yes. Now plus, this is what? The screen friction. I'm talking about base resistance. The base resistance will be equal to your C and C. C and C into what? Your base area. And base area will be what? If it is a circular pile, pi by 4 d square. And if it is a square pile, it will be simply what? B square. Yes. The area is what? B square, side length square. And this is what? For a circular area. This is for a circular area. Understood? Now, this NC, I told what? It is 9, right? So you can say this is the equation for finding what? The ultimate load capacity of a single pile in clay. Now this is known as what? The screen friction capacity, and this is known as what? The end bearing capacity. Now if I want to find out the total, then I have to add them. If I have to find out the total, I have to add them. Understood? Very good. This is what? Single pile-in clay. The next thing is group pile-in clay. It is what? Group pile-in clay. Okay. Now, group pile-in clay, we have to take lot of time. It will take lot of time to explain, and we cannot understand just by a formula. Okay. So, group pile-in clay, we cannot understand by a formula. You have to understand the concept. And this group pile-in clay, I have explained in details in the pile foundation in clay. You can visit this lecture and you can understand the concept. See, single pile-in clay is very simple. It is very straightforward. Okay, but group pile-in clay you have to understand from the diagram, and that I have explained in details in this particular video. Now, next thing is what? Piles in sands. Pile in sands. In sand, the ultimate load capacity equation remains same. Just what changes? This becomes the screen friction and base resistance. Yes. So here, if you remember for clay, it was alpha C into surface area plus what? This was your C and C into what? Base area. Yes, this was the equation for what? This is the equation for single pile in what? In your clay. Now when I take sand, the equation will change slightly. How it will change? In place of this alpha C, the equation will be K sigma average, the average vertical stress in the length of the pile, into tan delta. Okay, this particular thing changes, where K is the earth pressure coefficient, delta is what? Delta is the angle of friction between the pile and the sand, right? And this is area will remain same, area surface area will remain same, plus in place of this C and C, we will have the vertical stress at the base. Okay, the vertical stress at the base, that's it. The vertical stress at the base means what? If this is a pile, it is in sand, yes, you can find out the vertical stress at this particular base, right? Suppose I am telling it is gamma and length is L. Can I say this vertical stress will be gamma into L? Now it will be affected if this is water table. Yes, but I can certainly say that I can easily find out the vertical stress. This is what? Piles in sand. That is the next thing. The next thing is so many concepts of foundation engineering which I discussed just now. Means what? Your shallow foundation. Yes, shallow foundation means what? I can say footings, okay, where the depth of footing is less than the width. Okay, shallow foundations and pile foundations. All these concepts, okay, I have explained in details in the foundation engineering. Okay, please visit this lecture and you can solve many questions. The next thing is what? I have also solved 50 short questions. Okay, from various topics of foundation engineering. In this particular lecture, you can visit and you can understand the concepts also. I have not only solved, I have explained the concepts also. Okay. Okay, so normally what happens? Whenever there is some formula revision, thing starts with the basic definitions. I didn't start with the basic definition because you would have felt bored, you know, all this void ratio, water content, you would have felt bored. So therefore, I tried to cover all the difficult ones, right? The consolidation, shear strength, right? Bearing capacity, then stability of slope, earth pressure, okay, and then pile foundation, all the difficult ones first of all I wanted to touch, and then now we are going towards the basic definition. In basic definition we have first of all some volume ratios. What are the volume ratios? Void ratio, it is the volume of voids by volume of solids. Now what is porosity? Porosity is the volume of voids divided by total volume, right? Then we have what? Air content. What is air content? Air content is the volume of the voids, volume of the air voids by divided by the volume of voids, because the voids will contain either air or water. Now what is degree of saturation? It is the volume of water by volume of voids, right? And what is Na? This is the percentage air, okay? This is how much? This is the volume of air by total volume. Now these are what? These are all the basic definitions. There are volume ratios. Then we have what? Water content or moisture content. This is what? Weight of water. Okay, negative skin friction. Negative skin friction I have covered in the app. Once you can go and see that. Okay, I have covered in the app. Okay, you can see that because I cannot cover everything here. Okay, I cannot cover everything here. We have limited time. Okay, so that I have covered in the app. I think you are app student, right? You are app student, right? Swapnil, I have seen in you in classes. So in app you can go to pile foundations. Okay, you can go to pile foundations. There I have taken one full video on negative skin friction. Full video I have taught on negative skin friction. Okay, and then I have solved, the two videos are there. One with negative skin friction, second one will be numericals. Second one will be numericals on negative skin friction. Numericals on negative skin friction. Okay, so these two videos are there. You can go. It is in the section what? Learn with video lessons. In the section Learn with video lessons, you can find these two videos. Okay, Learn with video lessons. You can find these two videos. Okay, in that you go to first what? Pile foundation or deep foundation, you can say. And then you can see these two lectures. I have explained everything in details. And any other topic whoever wants to study, okay, all those topics of Geotech I have recorded and it is available in the BYJU'S Exam Prep app. It is available where? BYJU'S Exam Prep app. Okay. You can go and see all those videos. I have explained in this manner only. Okay, the basic definition is done, right? Then we have unit weights. So unit weights, I tell always one formula is very important. The bulk unit weight is how much? It is G plus SE by 1 plus E gamma W. Now if you know this formula, you put S is equal to 0 for dry soil, you will get what? Gamma D is equal to G gamma W by 1 plus E. Why the S is 0? Because dry soil degree of saturation is 0. If we have saturated soil, fully saturated, S is equal to 1, and in this equation what will happen? It will become G plus E by 1 plus E into gamma W. This is what? The gamma set. Now, if you want to find out gamma submerged, this is what? Gamma set minus gamma W, that will be how much? G minus 1 you can do, okay? You already have this G saturated, yes? So you can see that you can remember this formula and this formula by just remembering one formula. Then some important relationships, okay? We should know some important relationships we know. What are the important relationships we should know? Most important is ES is equal to what? W into G. Then another important relationship is what? Air content plus degree of saturation is what? It is 1, right? Another important concept, what? If you want to find out the volume of solids, it is what? Total volume by 1 plus C. If you want to find out the weight of solids, it will be what? Total weight by 1 plus water content, right? These are the few important relationships which you should know, right? And all these formulas. You see, if you know this formula, I can put here and get what? Z plus WG. So G plus WG, I can take what? G common, and I can say gamma T will be equal to G gamma W 1 plus W by what? 1 plus C. From here, what I can say, this is what? This is gamma D na, and I can say that gamma D is equal to gamma T by 1 plus W. You see, easily I can remember all these equations. Okay. Now, one major question they ask is from boro pit. Okay. Boro pit is what? Suppose we have, dug a pit like this, okay, and we have taken the soil out, okay. We have taken the soil out from here, and we have filled the area, or we have constructed embankment, okay. Either we have filled an area, suppose one field was there, either we have filled it somewhere, or we have constructed an embankment. So either fill, or I can say what? We have constructed an embankment, okay. So if we have done this, and this is what? This is the we can say borrow pit. Why it is called borrow pit? Because we have borrowed soil from it. It's a pit from which we have borrowed the soil. So what happens here? You see, in this, the volume of solid don't change. So here the volume of solids will be what? A total volume by 1 plus E1. Volume of solids here. And here the volume of solids will be V2 by 1 plus E2. Why? This is the equation for volume of solids. So whatever disturbance happens, whatever volume changes happen, volume of solids will not change, because solids, you can say the solids are incompressible in soil mechanics. So if I equate both of this, I can say V1 by V2 becomes equal to what? 1 plus E1 by 1 plus E2. Now this is the one formula I can say. Now if I multiply in this formula both numerators, so I can write down the first formula is V1 by V2 is equal to 1 plus E1 by E2. That's a lot of questions from this. Now the second thing is, if I multiply G gamma W here and G gamma W here, you see this G gamma W by 1 plus E is what? It is gamma D2, right? So I can say V1 by V2, denominator I will get what? Gamma D2, and sorry, I'll get this as gamma D2 in the numerator, and you see this term by this G gamma W by 1 plus E1 is what? It is gamma D1. Yes. Or I can easily remember this equation how? The volume is directly proportional to 1 plus E and the volume is inversely proportional to what? 1 by gamma D. Yes. So questions are asked from me. This is what borrow pit and fills. The next thing is the index properties and the soil classification. Yes. Now index properties are so many. Yes. Liquid limit, plastic limit. Yes. Then liquidity index, plasticity index, right? And then I can say shrinkage index, right? Shrinkage limit, yes. Then shrinkage ratio, right? Flow index, okay. Then sieve analysis. All these things I have covered in the index properties video. You can always visit this video and you can complete that. So this was a 1.5 hour session on what? Where we try to complete all the important formulas. Yes, you can see we try to complete all important formulas, you see, and the videos which I told to refer are what? You refer these videos, time for consolidation and numericals in time for consolidation, right? You can refer primary consolidation video, you can refer the degree of consolidation video, yes, you can refer the permeability of soils video. How to get PDF? Yeah, the PDF will be available. Okay, the PDF will be available in the Telegram group. Okay, so there is a Telegram group link given in the comment section. Okay, there's a BYJU'S official Telegram group is there. Okay, BYJU'S official Telegram group is there. So you can